Welcome to CSEGuru. In this session, we will discuss data structure and applications. In that, we are going to discuss stack operations with array representation. So what is stack? Stack is a linear data structure. That is, elements will be stored in sequential memory location where the elements are added and removed only from one end of the stack called top. Okay, so if we are considering the stack in the sense, here insertion and deletion will happen only at the top end of the stack. And stack is called LIFO data structure. What is LIFO? Last in, first out. That is, what is the element you have pushed into the stack at last, that will be removed from the stack first, because it will always perform operation with the top end of the stack. So, element pushed into the stack will be placed at the top of the stack. And if you want to delete it in the sense, only we can able to delete the top element of the stack. So, stack is a LIFO data structure. There are three basic operations we can able to perform with stack. One is push operation. Push is nothing but insert operation. Normal insertion, how we will do it in other data structures. So, that operation is push operation in stack. And pop is delete operation. So, the delete operation in other data structure, here we will call it as pop in stack. Peek operation, it will display the top element of the stack. So, push operation will add an element to the top of the stack. So, element will be added only at the top of the stack. And pop operation in the sense, it will remove or delete an element from the top of the stack. Because what is the element you have pushed last? That will be placed at the top of the stack. So, if you want to delete it in the sense, first the top element only you can able to delete it. Then only the next element you can able to access it. Okay, so if you want to delete also, the top element only will be deleted. The last element what you have pushed into the stack, that will be deleted first. And what is the first element you have pushed into the stack? That will be deleted at last. And a peek operation, that will return the value of the topmost element of the stack. Suppose if this is the top of the stack in the sense, if you are implementing peek operation in the sense, it will return 15. The top element of the stack is 15. So peek operation will display the top element of the stack. Okay, so these three are the basic operations we can able to perform with stack data structure. Now, we are going to discuss all these three operations with array implementation. Already we have discussed there are two types of implementations in stack. One is array implementation and another one is linked list implementation. Now, we will discuss the basic operation of stack with array implementation. So, first is push operation in array implementation of stack. So, push operation, it is used to insert or push an element into the stack. That is, it will add a new element into the stack. That is called push operation. It is otherwise called insert operation. Generally in stack, we will use the name push only. The new element is added to the topmost position of the stack. So, whenever you want to add a new element in the sense, that element will be added at the top position of the stack only. Okay, here top will get incremented to next position, and in that position only new element will be added. Before inserting any new element, we have to check the condition. Top is equal to max minus 1. So this max is nothing but the size of the stack. What is the size of the stack? You want it, that is you want to use in the program, that you need to declare it. So the main drawback of array implementation is its size only. Once you have fixed the size, only with the size only you can able to implement. During execution, if you want to increase the size, that is not possible. Okay, so that size of the stack represents the max variable. So what is the max value you have given? You have to check it max minus 1. Okay, if top is equal to max minus 1 in the sense, we can able to perform insertion. Otherwise, stack is full. Meaning is, what is the maximum position you have allocated? All the positions you have utilized. That is, you have placed the element. Okay, so in that case, stack is full. So before performing insertion, you have to check top is equal to max minus 1. If this condition is true in the sense, you can able to perform insertion. Suppose if this condition is false in the sense, stack is full. That is the meaning. So you cannot able to perform insertion in full stack. Then in that case, it will display overflow message. That is, you are trying to insert a value to full stack. Already stack is full. If you want to insert in the sense, that is not possible. So in that case, it will display overflow message. Okay, overflow message in the sense, stack is full. That is the meaning. And algorithm, if you are considering in the sense, step 1, we have to check the condition before insertion. top is equal to max minus 1. If this condition is true in the sense, it has to display overflow message and go to step 4, comes to an end. That is, if top is equal to max minus 1, you cannot able to perform insert operation, so go to end. Suppose if this condition is false, go to second step, set top is equal to top plus 1, increment the top position, and stack of top is equal to what is the value you are going to insert, the new value. Place that element in the top of the stack. Okay. So here array implementation in the sense, element will be stored in sequential memory location and the first location will be 0. Because array, if you are considering, the size of the array will vary from 0 to n minus 1. Okay. Suppose n value, if you are giving 10 in the sense, the size of the array will vary from 0 to 9. That is the meaning. So in array implementation, the first location will start with 0, next 1, 2, 3, 4, 5, 6 and 7. So here totally 8 memory locations. Okay, n value is 8 and this is n minus 1. That is 8 minus 1 if we are considering, the value is 7. So totally 8 memory locations it has allocated. Starting location is 0, last location is 7. That is the meaning. Okay. And now we have placed the element. The first element is there, second element, third element and fourth element. Okay. So now top will represent the third position and the remaining 4 locations are free only. Okay. So now if you want to perform insertion in the sense, so here also it is 1, 2, 3 up to 7, n minus 1. Okay. And here 15 is there, 20 is there, 30 and 40 is there. Now top is representing to third position, third memory location. Suppose if I want to place a value 90. Okay. So here increment the top position by 1. Top is equal to top plus 1. Top is 3. 3 plus 1, it will goes to 4. Now the top position will point to 4. And what is the value you want to place it? It is 90. So 90, place it in the next memory location. Okay. Now element 90 is placed here. So this is called push operation in stack. Okay. So here condition is, before inserting, check top is equal to max minus 1. Why we have to check? Suppose element here it is pointing. Okay. All the elements we have placed 1, 10. Now all the elements occupied in complete memory location, whatever we have allocated. So now stack is full. Suppose in this condition, if you want to perform insertion, here you have to check top is equal to max minus 1. What is the max value here? Max value here is 8. Okay, max value here is 8. 8 minus 1 in the sense. Here you will get it as 7. So now top value is 7. If this condition is true in the sense, it will print overflow message. You cannot able to perform insert operation, right? You have allocated only 8 memory location. All the 8 memory location elements are there. Then how we will perform push operation? That is not possible. So here stack is in this condition, stack is full. Suppose top is pointing to third memory location and if you want to perform insert operation, this condition will fail. So increment the top position, place the value at the top position. Now top will point to 4. That is it. So this is called push operation in stack. Next, pop operation using array implementation of stack. So here pop operation is nothing but the delete operation used in other data structure. Here in stack we will use the term pop. So this pop operation will delete the topmost element of the stack. Here no need to mention a value. What do you want to delete? It is not required. Just implement the pop operation. What is the topmost element of the stack? That will be directly deleted. And before implementing the pop operation, you have to check the condition whether top is equal to null. Suppose if top value is null in the sense, meaning is there is no element in the stack. So if there is no element, stack is empty. So you cannot able to perform delete operation with the empty stack. That is not possible. So here you have to check the condition before implementing pop operation. Check top is equal to null. If this condition is true in the sense, stack is empty. Otherwise, suppose if this condition is false in the sense, you can delete an element from the top of the stack. Suppose if stack is empty in the sense, it will display underflow message. Underflow in the sense, there is no elements in the stack. Stack is empty. Okay, cannot able to delete an element from the empty stack. It will display the message. And what is the algorithm in the sense? Step 1, we have to check whether top is equal to null. If this condition is true in the sense, just it will display underflow message and it will go to step 4 and the program comes to an end. So you cannot able to perform pop operation with empty stack. Okay. Suppose if this condition is false. For example, here this is the array representation of stack and here elements we have placed. Okay. So now top is pointing to 4th memory location. Okay. This is the top position. Remaining 3 memory locations are empty only. So now top is pointing to 4th memory location. So if top is equal to null, we have to check it. If this condition is false in the sense, go to step 2. Set value is equal to stack of top. So value here is 30. Okay. And set value is equal to stack of top. Stack of top is nothing but 4th position and value is 30. And then top is equal to top minus 1. Just to decrement the top position. You have to decrement the top position and the top now it will point to 3. So here 15, 18, 20, 25 is there. So after implementing the pop operation, what will happen? Decrement the top position. So if you are decrement the top position, automatically value will be deleted. Okay. And what is the stack of top value? That will be placed with the variable value. So if you want to display the deleted element in the sense, you can display this value. Otherwise, simply if you are decrementing the top position, automatically the top element will be deleted. Now top will point to 3rd position and it will point to the value 25 here. So this is pop operation in stack using array implementation. Next, peek operation using array implementation of stack. Peek is an operation that returns the value of the topmost element of the stack. So peek operation, just it will refer the top element of the stack and it will display its value. So before implementing peek operation, we have to check the condition whether stack is empty, like pop operation. If it is empty in the sense there is no element, you cannot able to implement peek operation also. Okay. So push operation in the sense you have to check whether stack is full. Pop and peek operation you have to check whether top is equal to null, meaning a stack is empty. So if top is equal to null, if this condition is true in the sense, it will print the appropriate message. If it is null in the sense, no element in the stack. So the peek operation cannot able to display the top element. Otherwise, suppose if this condition is false in the sense, just it will return the value. And here if you are checking the algorithm, first we have to check top is equal to null. If this condition is true in the sense, just it will display stack is empty and it will comes to an end. Program comes to an end. Otherwise, just it will return the top element of the stack. What is the top element of the stack? It will display in the output screen. Here, the memory location will start from 0 to n minus 1. Totally, n value here is 8. That is max value here is 8. Okay. And here we have placed the elements. Okay. Now top is pointing to 4th position. So if you are implementing peek operation in the sense, it will return the value 50. Peek operation will return the value 50. It will display the top element of the stack. Okay. So before implementing, you have to check top is equal to null. If this condition is false in the sense, it will implement peek operation and it will return the top element of the stack. Okay, 50 it will return. What is this variable? Which memory location this variable is pointing? That memory location value it will display. That is peek operation. Okay. So this is all about operations of stack using array representation. We have discussed 3 basic operations of stack: push operation, pop operation and peek operation using array implementation with example. Thank you for watching this video.